Hey, I'm Francesco, and this is my lab report. I chose as my adventure for this physics laboratory to examine whether friction was a constant force acting on the ball. And I decided to create a computational model to evaluate the effect of friction on the ball. However, the results deemed as a failure. However, I can tell you why. If you will just go ahead and listen to my presentation. So, in the video that I analyzed, and using the concept of friction, I decided to analyze the video of a friend of mine that was kicking a ball in a soccer field. From the graph, it was possible to see, this graph above here, that the ball was like losing velocity, and the graph, from the graph represented displacement. As you can notice that the graph was like slightly approaching to zero as time passed by. So I decided to use the equation for friction, which is the following one here, which is mu sub k multiplied by the normal force. And here you can see how it was translated on the Python. But then what is normal force? The normal force is the perpendicular force to the surface of the object that is moving. In this case, since the perpendicular force acting on the object is the weight force, the normal force will be the opposite of the weight force. So it's going to be, normal force will be equal to m times g times j hat instead of being negative j hat. And this is how it was translated on the Python. Notice that this vector is j hat. I presume that the only object that was acting on the system would be friction, because if you notice from the graph here, you can notice that the object's velocity is constantly decreasing, and so you might presume that the force acting on the object must have opposite sign to the direction of the object moving. So I had to apply Newton's second law of kinematics to predict the new velocity. In this case, I use F as F net, the force of friction, for the previous assumption that I made. Now, in order to determine as force of friction, as net force on the object, friction, I need to first determine the constant mu of k. But now, how do we determine it? On this first slide, this is the first assumption that is made. Then there is this second slide. And the data from tracker, both the position and time data, will be plugged in from this derivation that was done. And therefore, the values determined was this following one. But now, I wrote all this following things on the code. I used as maximum time step 5.467, as well as the maximum time step from here. And then I ran the code. From what you may notice is that you can notice that the object, strangely, is moving upwards when it should actually move rightwards. Well, there are many reasons why there was such errors. The graph that probably shows that friction was not always constant, but would it be or wouldn't it be? Then another mistake was that friction is usually measured on a flat ground, but in this case, there was grass, and then you can notice also that there was also some slight slope, and both probably due to the land conformation and also because of perspective. Then the computational model failed to predict the function of the friction as a function of time because the ball was acting linearly, but it showed like a parabola of a sphere moving upwards. Also, the force from the kick was still acting on the ball, so perhaps the friction force did not completely cancel out the force from the kick. Then, the type of friction that actually is acting on the ball is actually called rolling resistance, and is a type of force similar to the drag force that acts on an object falling from lab 2, but instead it is a force that opposes the motion of rolling objects. And last, friction as taken into account from the following formula that was used here did not properly describe the motion of the object. The main reason probably was because, in this case, the friction appeared as an object moving upwards, when actually friction is a force that moves opposite to the way that the object is moving. So friction acted more as a force like gravity, when actually it should not.